they want us to solve 3 cos 2x equals to 3 plus sin 2x. Solution. Now we know that cos 2x is given by exponent 2x plus exponent minus 2x all over 2, and then sin 2x is given by exponent 2x minus exponent minus 2x all over 2. Okay, so we can replace in the given equation, and that now here we have 3 into exponent 2x plus exponent minus 2x all over 2. So this equals to 3 plus, we replace sin 2x by this, so equals to that plus exponent 2x minus exponent minus 2x all over 2. Now we can open up the bracket here, so this is the same as 3 over 2 exponent 2x plus 3 all over 2 exponent minus 2x. This equals to 3 plus a half exponent 2x minus a half exponent minus 2x. Now we shall group like terms. We can have this as 3 over 2 exponent 2x. So this is like term with this one. So we shall have this minus a half exponent 2x, and then this and these are like terms, so we shall have plus 3 all over 2 exponent minus 2x. This crosses equal sign, becomes plus a half exponent minus 2x. This equals to 3. Now we can subtract this 3 over 2 exponent 3x minus a half exponent 2x. The LCM here is 2, so we have 3 exponent 2x minus exponent 2x. Then the LCM here will be 2, so we have 3 exponent minus 2x plus exponent minus 2x equals to 3. So here we have 3 exponent 2x minus exponent 2x, which remain with the 2 over 2 exponent 2x plus 3 exponent minus 2x plus exponent x. We have 4 exponent minus 2x all over 2 equals to 3. These two and these two cancel, so we have exponent 2x, then plus 2 here 1, 2 here 2, so we have 2 exponent minus 2x equals to 3. Now I can write this equation as exponent 2x plus 2 over exponent 2x equals to 3. Now from here, we can multiply both sides by, we can multiply through by exponent 2x, so that here we have now exponent 4x, we have exponent 2x dot exponent 2x plus 2 equals to 3 exponent 2x. We are multiplying through by exponent 2x. So exponent 2x times exponent 2x, we have exponent 4x plus 2 equals to 3 exponent 2x. Now we can cross 3 exponent 2x on this side, so that we have exponent 4x minus 3 exponent 2x plus now 2 equals to 0. So we shall form a polynomial here. We shall let k equals to exponent x. So if that is the case, then here we shall have k raised to 4 minus 3 k squared plus 2 equals to 0. So we need to factorize this polynomial. We need to look for the value of k when we replace in this equation. We get 0. Let us try when k equals to 1. When k equals to 1, this equation will be f of 1 will be equal to, this will be 1. Here k is 1, so 1 raised to 4 is 1 minus 3 times 1 is 3 minus 3 and then plus 2. This one will be 0. So therefore, k minus 1 is a factor of this equation, in that when we divide through this equation by k minus 1, we shall get 0. Therefore, we shall divide through by k minus 1. So k minus 1 into, now we shall write this one as k raised to 4. So we need to have all the powers of x. So here we shall reduce plus 0 k raised to 3, then minus 3k squared plus 0k plus 2. The reason why we are introducing this is for easier to enable us to work with a lot of ease. But remember, 0 times k, this is 0. So we ask ourselves, how many times do k goes into k raised to 4? It goes there, k cubed. So k cubed times k, we get k raised to 4. K cubed times negative 1, we have minus k cubed. Then we subtract, we have 0. So this is 0, 0 minus k cubed to remain with k cubed. Then we drop minus 3k squared. We again ask ourselves, how many times do k goes into k cubed? It will be plus k squared. So k squared times k, get k cubed. K squared times negative 1, we get minus k. We again subtract here it will be 0. So you have negative 3k squared minus k squared. So it's the same as 3 minus 3k squared plus k squared will remain minus 2k squared plus, we drop 0, 0k. So how many times do k goes into negative k squared? It goes there. Negative 2k, so negative 2k times k, get negative 2k squared. Negative 2k squared times negative 1, it will be plus 2k. We subtract, it will be 0, here it will be negative 2k. Then we drop plus 2, so k goes into negative 2k minus 2 times k, we have minus 2k, negative 2 times 2, negative 1, we have plus 2. So to divide that completely, so the factor we have here is, we have now reduced polynomial to a cubic polynomial, which is now k plus k squared minus 2k minus 2. Now we again look for a number, the value of k that when you replace in this equation we should be able to get 0. We can try when k equals to negative 1. So what would be our f of negative 1? We can try if x, so this would be negative k negative 1 cubed to negative 1, then plus negative 1 squared into plus 1. So this will be plus 2, because this case negative 1 then negative 2, we have 2, then minus 2. So this one will equal to 0. Therefore, if this is the case, then it means that k plus 1 is a factor in this that can divide it completely in this equation. So we can now divide a cubed plus k squared minus 2k minus 2. So how many times 2k goes into k cubed? It will be k squared. When you multiply, you have k cubed. K squared times 1, you have plus k squared. When you subtract here, you have 0, 0. We drop minus 2k minus 2. So k goes into minus 2k how many times? Minus 2. When you multiply, you get negative 2k. Negative 2 times 1, we get negative 2. When you subtract, we get 0. So we can collect all our factors. The first factor was k minus 1. So we have k minus 1 was the first factor. The second factor is k plus 1. K plus 1. And then we have this factor k squared minus 2. So all this equals to 0. So now these are the factors of this polynomial. Therefore, from here we can get several values of k. So from this first bracket, we can say that k1 equals to 1. From this, we can say that k2 equals negative 1. Then from here, we have k squared equals to 2. Therefore, k3 equals to plus or minus the square root of 2. So these are the possible values of k. But remember, k is not the result. Now we go back. We had said that k equals to exponent x. So where there is k, we are replaced with k1, or k2, and then K3. Let's start with the K1 here. So we shall have 1 equals to exponent x. 1 equals to exponent x, but 1 is the same as exponent 0, which equals to exponent x. Exponent x exponent will cancel out. Therefore x equals to 0. That's one value of x. And then we can also get the value of x from the positive value of k here. So we can say that if k3 equals to positive root 2, so we shall say exponent x equals to root 2. Now, if exponent x equals to root 2, and therefore we can say that the ln of root 2 equals to x. So get ln of root 2, ln of root 2, 0.35. X equals to 0.35. So these are the two possible values of x. X equals to 0.35 or x equals to 0. Thank you for listening and watching.